Hello friends, now we shall see the derivation of conditions for a trapezoidal section to be most economical. I hope you all remember what an most economical channel section means. Most economical channel section means a section that gives maximum discharge with minimum construction cost. So now let us see the derivation of the conditions for a trapezoidal channel section to be most economical. This is the figure of a trapezoidal section. This is the free surface. Let d be the depth of fluid. Let us assume the fluid as water. So d is the depth of water. Let theta be the angle that this sloping side makes with the horizontal. And let b be the base width or bottom width. And 1 in n be the side slope. Side slope, not the bottom slope, side slope. So the side slope be 1 in n. So from similar triangles, we can write this dimension as nd and this as d. This is something that we have assumed. So from Pythagoras theorem, this side will be d into root of n square plus 1. Now let us mark all the sides. A, B, C, D and E. So before starting the derivation, please keep these two equations in your mind. Actually, we had made this equation during our lecture hours. Vectored area B plus nd into d and vectored perimeter B plus 2d into root of n square plus 1. You can use this equation or you can use the equation for area of a trapezoidal section. And that is the base width plus top width by 2 into depth. Here it will be BC plus AD by 2 times D. It will be like BC plus AD by 2 times D. You can use this equation and you will end up here. So if you by heart these two equations, it will be easy for you to solve. So now let us start deriving the condition. A is equal to B plus nd times d. Therefore, A by d will be equal to B plus nd. Is in turn B is equal to A by d minus nd. Let us mark this as equation 1, this as equation 2. Excuse me. Now vectored perimeter P is equal to B plus 2d into root of n square plus 1. Substituting the value of B in this equation, we can write P is equal to A by d minus nd plus 2d root of n square plus 1. Just take this as equation 3. This one as equation 3. Now we know that for a section to be most economical, P should be minimum, or dP by d of d should be equal to 0. So please remember, for a rectangular section, we had used depth of flow as y. So there the condition was dP by dy equal to 0. But here we have used d instead of y. That's why the notation changed to dP by d of d equal to 0. So for the most economical section, P should be minimum, dP by d should be equal to 0. So now let us take that condition. You have to differentiate this with respect to d. You have to equate it to 0. So let us do that. D by d of d p should be equal to d by d of d of a by d minus nd plus 2d into root of n square plus 1. Let's take a fresh page and do. This should be equal to 0. Forgot to write that. Differentiating, we get a by d will be minus a by d square, since a is a constant, d is the variable, minus n, d will truncate, d will disappear, plus d again constant, 2 into root of n square plus 1 will be equal to 0. Or we can write, taking a by d square and minus n to the right side of the equation, we can write a by d square plus n is equal to 2 root n square plus 1. Now we know that a is equal to b plus nd into d. So let us substitute that over here. So let us write, substituting value of a from first equation from this equation, we can write b plus nd times d by d square excuse me plus n is equal to 2 root n square plus 1. We can cancel this d and this square, so what that will remain is b plus nd by d plus n is equal to 2 root n square plus 1. Taking the LCM over here and simplifying, we will get b plus nd by d will be equal to 2 root of n square plus 1, or b plus 2nd by 2 is equal to d into n square plus 1. I took this d over here and I took this 2 to this denominator. So this is the first condition. B plus 2nd happens to be, let us see what is b plus 2nd. b, nd, nd. So b plus 2nd is top width. B plus 2nd is top width. Top width by 2 equal to d into root of n square plus 1 is the side slope. Not side slope, sloping length. d into root of n square plus 1 is the sloping length. It's the sloping length. Is the one of the sloping side. So this is our first condition. Top width by 2 is equal to one of the sloping side. I hope this was clear to you. If you have any doubts, you can contact me. Now let us see the condition for hydraulic mean depth. Hydraulic mean depth R is equal to A by P. A is equal to B plus ND times D, and P is equal to B plus 2D into root of n square plus 1. Now what is B 2D into root of n square plus 1? So here we have 2D into root of n square plus 1 is B plus 2nd. So let us substitute that over here. That is P equal to B plus 2 ND. From here B plus 2 ND. B plus 2 ND. That is 2B plus 2ND, taking 2 outside, 2 into P plus ND. It is P. Now let us see what is A by P. R is equal to A by P, which is equal to B plus ND times D divided by B plus ND. B plus ND get cancelled. So what remains is D by 2. So we can write R is equal to half of depth of flow. This is the second condition. Half of depth of flow.